Hi everyone, so today we've got Fernando again, who has just completed ROS Basics, and they will be giving us a presentation on that. So as always, we'll begin by seeing a presentation on his code base running on the real robot, and then after that we will get to ask him a couple of questions after he has finished presenting his project. So I'll now leave the platform to him so he can begin his presentation. Alright, whenever you're ready, Fernando.
Well, I don't know why the platform is cool. I can open the project.
Alright, you can maybe refresh it or just wait for it a little bit.
I will wait because I have just 18 minutes for the robot.
Okay.
I see. I have time. But I don't know why the ROS project. I don't know, it never pass. Maybe I want to enter again to the ROS. My ROS project. So it does ROS project. Maybe if I do that, I will see. Wow.
It's showing that you are connected, so let's wait for the ROS checks to load a little. It will load eventually.
What's happening? Take more. Tanto tiempo en el plan. Oh,
okay, there we go.
we are connected to the robot. I think it's a responsible position. Yes. So yes, it's a good position. Well, like that, we can see all the codes. And I want to launch the project.
Okay.
I have got a server launch. Sorry. First, let's see what I say. Yes. This process, we want to find all the. First, we want to find the wall. We make all the plan. Yes, we identify the wall. And we do all the trajectory. In this part, well, I do the same idea to make sure what's the distance of the robot. To be able to distance to the robot, yes. Yes, so we have to stop in this part. Yes, we have all the register.
Okay. That was
all complete, and the distance 5.44 meters. Yes.
That was smooth.
And have 80 registers.
Okay.
80 points. Yes. So first we will to explain what is doing the project. Yes. In this part we have find, a record, and the setup part. We start with that. Yes. So, well, in this part we have the wall follower cell. Wall follower. In this part, this node is called wall follower node. Yes. It is responsible for following a wall using the laser sensor scan while monitoring odometry with an action client. In this part, we have this also this node interact with the service client. In this case, is directly on the firewall, and an action client. An action we interact with an action. In this case, an action client is the record alone that measures the distance traveled and all the points to register, as we could see. So part of laser yes. So I'm going to define the contract, yes. Define the contract, the client service. Well, in that part, the pilot client of the follow all the world, we have the laser data processing. This part, the values of the several indices around the angle are averaged to smooth the reading. Yes, the following are updated in the right distance from distance wall right. If the distance of the right is less than 1 meter, yes. That's the laser cover. In this part, we define the right index. In this part, I think it was the most important because when I try to do this code, always the robot don't move very well because I don't define well the right distance and the front the right index and the front index of the laser. Yes, because the laser all the maybe I don't know is 360 degrees. So I put all this. If you refer from the index of the front, you have to put 360 degrees, and if you have the right index is the 270. That was the part two. I do all the project because if you put another angle, it's don't move well. And if I try every angles and I find these angles that the robot can move.
Okay.
So
okay.
That's from this control. Well, in this part, I try to do the same of they have a safe distance, or try to have a safe distance. In this case, I put if there are obstaculated if there are an obstacle ahead less 0.5 meters, 0.5 meters, we turn left. It is a part of that. Yes. In the right, in the wall. So for the wall on right, that is defined in the right. Yes. So in this part, if there is there is a wall on the right, if it is too far away, more than 0.35 meters, we turn right. If it's too close, maybe less to 0.2 meters, we turn left. Yes, if it is a good distance away, to go right. Yes, in this part. If there is no wall on the right, we turn right, looking for it. Yes. This is the part we don't detect them. Well, that's just the most important for the ROS follower. Then we go to the firewall server. In the firewall server, we define the servers that perform the 3 sequence actions. First is rotate until the wall is in front of the robot. Then we move toward the robot until it is about 30 centimeters away. Then we rotate again to the wall to the right of the robot. In this case, the laser index is 270. Well, they will publish those, the subscription for the scan and the service. We have the service. Therefore, the service we define the firewall. And the next part I see, because I have problems to do this part because I don't define the firewall. Yes, callback groups. I think this was the most important recall, because when I do another group, because it's a part, I remember we explained that you explained a lot in the course. When you use, depends of the groups or you use, the program maybe can function or not, or don't do that. In this case, I put for this part mutual exclusive. Yes, mutual exclusive. Create the groups. And if you want to a part, we have a multi-threshold executor. If maybe when you say callback a group, avoid blocking between the subscription and the service. So we avoid this blocking between. That was the two part more important for this code. And I'm going to talk about just the function of we have is first the laser callback. Yes. In this part that we have that this can arrive is safe to arrive in ranges and this can receive is true. Yes. It is to indicate whatever the node has already received unless a message from the laser scanner. Then we have a get min index. In this we have the index of the laser beam with the shortest distance and the point closest to the robot, and this is used to rotate the robot until that point is directly in front of it. Yes. And then with the stop robot we send that topic will stop. Basically it's supposed to empty twice to stop the robot. Very useful to stop the within the process. Okay. We have to talk about the hand service. That's all the secrets. First, we define the sequence that executed when another node call the service. First, we wait for the first laser scan. Here, the robot waits until there is data from the laser sensor. Without check, it will then know where to move. Then we selected the direction of the nearest wall. We find the index of the laser with the shortest distance, the closest point, and then we have the mean index. In this indicate the angle where the wall is located. Then we rotate until the wall is detected in front the robot. Yes. And then we move forward toward the wall until in front distance. The distance is the range 0, yes, and is less than 0.3 meters. And then we rotate to align the wall to the right of the robot, and that's until the wall is at the angle to 270. Then we talk this time. Yes, because I find that the multi-threshold executor, that is the secretary, is launched to handle subscription service in parallel. Yes. So finally, I want to talk about the record. So the part where we could see all the points and the distance, and the total distance. In that part, well, the record alone service is enough to define an action servers, a subscription to the alone topic, and a timer position for the 1 second. Yes. We put the logic, and we could see in the same save column. In that part, we wait for active goal and valid position. We record the points. We calculate the distance from the last point and update it. We save the current point. We publish the feedback and check if it should automatically stop. So we check if it should finish automatically. We finish all the sequence if the robot is the total distance is more than 2 meters. The same we do at the last part, and then if the distance to the start is less to 0.20 centimeters or 0.2 meters.
Okay.
And that's all the conclusion of the part. Yes. And that's it. I think that's all of this part to the road to product.
All right.
I don't know if I can it work. So.
Yeah. All right. So, can you? Okay. First of all, very nice presentation. I really loved the code outline there and how organized your code is. I would like to ask, how did you deal with infinite readings? Because I saw you did something there, but can you explain to me what you did? I don't want to give it up. So, how did you deal with infinite values from the laser scan sensor?
Could you repeat in what part? In the firewall server?
Yeah. In your laser scan, right? When you receive your laser scan data, how did you deal with infinite values, right? Should be at the top. Yeah, should be at the top. Yes.
Sorry. We lost one.
It's fine. Yeah. Yeah, it's fine. Yeah. Somewhere at the top there. Can you explain to me what you did? Why did you choose to use stud infinite? Right. What were you trying to do there?
In that part, you have the chart.
Yeah, in the subscriber that receives your laser scan data.
Well, have to receive all the sequence. Well, you only have to receive the ranger of 270 and the 360 degrees of the all the ranger. When I investigated about the laser,
Mm-hmm.
we receive any kind of angle. I check that which another um, when I investigate the launcher of the laser scan.
Mm-hmm.
Well, I check we have to in this part you have to choose what part you define to the is it is right or what part you define is in front of the robots, and that was only to put in to identify. No? Yes.
Okay.
You only know what point is it if you try to if you only make a lot of proofs, just a lot of tries. That's
Mm-hmm.
very fast.
All right. Can you explain to me what is why did you choose to use a service, right, for your wall finder? Why did you choose to use a service instead of maybe an action or a message, for example, right? Topics. Why did you choose to use services there?
In the find service,
In the find
we
wall,
have to
in the find wall.
in the firewall.
Yeah.
Yes. So basically, I remember in the firewall we have we have to find the the more the near the near the near the near wall of the robot. So in this part we need to connect to the laser. We need to connect to the topic velocity to control this velocity. When you say the service, I think you refer to the client is in the wall service, no? Because you contact the client and the client is going to request to the firewall service, and you man you in this part you have to request of the position of the robot. Where is the robot? This maybe for more for localization. I think that you asked.
Yeah, mostly what I wanted to know was what was the logic behind choosing a service as a communication, as a form of communication instead of maybe why did you not opt for something like actions or topics? But no, it's fine. It's all right. Okay, the next question I wanted to ask you about is the use of. Did you speak about the use of mutually exclusive callback groups? Can you explain a little bit more why you chose those over maybe like re-entrant callback groups, for example? I want to know what was your reasoning behind that.
In the groups, well, I create
For your callbacks, yeah.
that's correct. Well, first, um, I remember in that part of groups we have a lot of types.
Mm.
First is the mutual exclusive.
Mm-hmm.
The so I don't remember, but well, I remember that it defines that how can you define the groups? You have any activities in parallel? Yes, maybe, or only one activity, one node is going to make a function, and another node can do, and maybe have to wait to that turn.
Right.
Turn.
Yeah, it's mostly
So,
it's mostly when you want to ensure that one executes after the other, right? You want to ensure that order of execution, right?
yes. So that I think that was the part I have a lot of difficulty because I don't understand in the first time that I check this part what does the mutual exclusive or what
Okay.
about the clock, and when I do the project have a lot of problems because the robot never do the two sequence I have to define. I decide to the robot make a turn and then have to go go toward go go toward to the to to get more near to the wall, but they don't do that. The robot always make a turn, yes,
Okay.
and don't do more tasks. So that was the part I was just to investigate. I go to the code books again and I check this part and I see if I would use mutual exclusive in this part of the creative code book, and if you multi-crash
so the mutually exclusive callback groups worked for you on that part. You didn't have that problem after choosing the mutually exclusive callback groups.
Yes.
Okay. All right. Oh, okay. I would understand if it would if it worked, right? But you must try to understand a little bit more how it ensures that it works, right? It's slightly different from having to try everything else and see what works, but not really understand why it works. But I think now you do understand that with the mutually exclusive callback groups, it's mostly because they ensure that one executes before the next, right? You cannot have them go concurrently because if they're in a mutually exclusive callback groups, the order is ensured. So yeah, but all right, thank you very much. I think well done, Fernando. So what we'll do is you hang around here and we'll finish our conversation on Zoom. All right. Alright everyone, so this was Fernando's presentation. We highly encourage all of you who would want to try the courses we offer certification on to do so, and then you can come and showcase your work. So until then, keep pushing your ROS learning. Bye bye.